So the secondary structure really is a reference to the initial folding of a polypeptide chain into shapes that are stabilized by the hydrogen and basically the backbone of the amino acid or the polypeptide chain. And what I really mean by that, like I'm going to again point out again and again, is this interaction between the NH and the CO groups on the amino acid. And here's what I mean by that. There will be an interaction when these two are together, and that really just forms, that is the basic principle of the secondary structure. The first kind of secondary structure we have is the alpha helix. The alpha helix really is just a reference to the helical shape that is formed when we have this kind of folding. And there are two kinds of alpha helix. We have a right-hand alpha helix and a left-hand alpha helix. Now, what is the difference between the right-hand and the left-hand alpha helix? So imagine you're this stick figure right here, and you're standing, and what you're doing is you're watching through this alpha helix like that. Now you're going to see that the alpha helix is going to unfold itself in an anti-clock fashion or a clockwise fashion. If it's going the clockwise fashion, which means that it's like the clock we see on the wall, it's going to end up looking like this. It's going to open up like that. It's going to go like that. Now, if it's clockwise, it's a right-hand alpha helix, and if it's anti-clockwise, which means it's going on the left-hand side and the opposite side of what I just said, then it's a left-hand helix. And we want to mention real fast that the right-hand alpha helix is more present in nature than the left hand, and the whole reason is because the right hand is more chemically stable than the left hand. The next kind of secondary structure we have is the beta-plated sheets. Now the beta-plated sheets is really, just to make it simple, is we have these amino acids that are kind of on top of each other, and they make these beta-plated sheets. And we have two kind of beta-plated sheets. The first one is when we have anti-parallel beta-plated sheets. What that really means is the backbone is running in opposite directions. We have carbon, nitrogen, and then we have nitrogen, carbon, and really that just boils down that it looks something like this. It's a little messy, I apologize for that, but the whole essence of this is really that you have the NH group interacting with the CO group, just like the first example, but this is more of a different structure. And really the same thing is applied on the parallel strand. And instead of the instead of the carbon nitrogen and the nitrogen carbon, we have a carbon nitrogen just like that on top of each other, and that looks like this. Then this is a better representation of the other one, and this is just an example of the interactions that are happening between these two strands over here. And the last thing we want to mention with secondary structures is the reverse turn. Now we want to think that, all right, we have these amino acids that they're interacting with one another, but what happens when these turns come? What's happening over here when these turns come? So when these turns are coming, we have amino acids that are lining up to form a hydrogen bond between. So let me just explain that real fast. So at the end, we have 4 different amino acids. So the first amino acid is N. The second one is N plus 1, N plus 2, N plus 3. That's the 4th amino acid. On the first amino acid and the last amino acid, their COs, the CO group on the first amino acid will be interacting with the NH group on the 4th amino acid, and this creates a very strong hydrogen bond that kind of stabilizes the entire molecule. So the polypeptide. So what I really want to say is it all boils down to the interactions between the NH and the CO groups and the H plus groups that are interacting with the OH as well. So that's all secondary structures are.